Here are the answers for the section 6-4 homework. We're starting on page 225 with some graphs. We're going to graph function f. Function f takes on two different values depending upon the value of x. Sometimes function f is equal to 1, but only if x is greater than or equal to 0. And other times function f is equal to 2, but only when x is less than 0. So this part right here gives the function value, the y value. This part right here gives the domain, or the x value. Our function will consist of two parts. Let's graph this first statement here. Y is equal to 1 whenever x is greater than or equal to 0. So here's where x equals 0, and there's a dot at 1. When x is greater than 0, we still get dots at 1. For example, when x is a half, there's still a dot at 1. Or when x is 1, there's still a dot at 1. Or when x is 3, there's still a dot at 1. This makes a horizontal segment that continues to the right forever. Now let's graph the second part of function f. Sometimes there's a y value of 2, but that happens when x is less than 0. Here is where x is 0. Let's go up to a y value of 2 and put a mark on that, but we're going to use an open circle dot because y doesn't equal 2 when x is 0. However, when x is less than 0, we will have dots up at a height of 2. For instance, when x is negative 1, go up to a height of 2 and put a dot. Or when x is negative 2, go up to a height of 2 and put a dot. What we're going to have is a horizontal segment going to the left forever. Notice that this piece here has an open circle endpoint, whereas this other piece has a closed dot endpoint. Number 3, function f takes on 3 different values depending upon what x is. Sometimes f is at a height of 3. Other times the function is at a height of 0. And other times it's at a height of negative 1. It all depends what x is. Let's start with this first piece at 3. That happens whenever x is less than 0. Well, let's point at where x is 0 and go up to where y is 3 and mark that with an open dot. I'm putting an open dot there because this arrow symbol does not have that or equal to piece. When x is less than 0, meaning going to the negative direction, we get dots at a height of 3. So the fastest way to show them is a horizontal segment going to the left forever. That takes care of this first part of our function. Let's come down here to the second row and graph this one. We have a y value of 0 when x is 0. When x is 0, y is 0. That is the dot 0, 0 right here at the origin. Now let's go to this third row and graph this last part to the function. We have a y value of negative 1 whenever x is greater than 0. So right here at the origin is where x is 0. Go down to a y value of negative 1, mark it with an open dot. But as x becomes greater than 0, like when you go over to x is 1, then you have a dot at negative 1. Or when x is 1.5, there's a dot at negative 1. Or when x is 3, there's a dot at negative 1. The fast way to show this is a horizontal segment going to the right forever. Number 5, again, our function is built out of 3 parts. Let's tackle each of them one at a time, starting with this first statement. We're going to have dots at a height of 0 whenever x is less than negative 5. So let's find where x is negative 5. That's right here. And mark that with an open dot. I have an open dot because this symbol has no equals to bar. Then draw a segment going to the left forever. That takes care of this first row of our statement. Now let's come down here to the middle. We're going to have dots at a height of 1 whenever x is between negative 5 and 0. So here's negative 5. Go up to a height of 1 and put a closed dot on that. I have a closed dot because this symbol does have the equals bar. When x is -4, the dot is at a height of 1. When x is -3, the dot is at a height of 1. We're going to get a horizontal segment. Now, how far to the right does it stretch? Where's the end point? And that's where you look at this piece. This segment goes all the way over to where x equals 0. So right here is where x equals 0. Go up to 1 and put a closed dot. Then we can draw a horizontal segment connecting those dots. That represents the second row of function f. Now this last one, sometimes function f equals 2, whenever x is greater than 0. So here's where x is 0. Go up to a height of 2, put an open dot on it. Then graph horizontally going to the right forever. This function has 3 distinct pieces to it. Number 17 is a story problem, but I've transferred the story problem into the same format that we have. Instead of calling my function f, I chose to call it r because it seemed to be about rentals. Instead of using the letter x, I chose the letter t because our independent variable involved how much time we're renting for. One thing we're told is that it costs $5 to rent equipment for up to 1 day. I represented that with this statement. The phrase for up to 1 day means that t has to be between 0 and 1. Then we're told it costs $10 to rent equipment if you rent it between 1 and 4 days. And here's how I represented that concept, between 1 and 4 days. Finally, we're told it costs $15 to rent the equipment if you rent it for more than 4 days. And here's how I showed more than 4 days. Let's graph these pieces. We are at a height of 5 whenever we're between 0 and 1. So here's where t is 0. Go up to 5 and mark it with an open dot. Then we're going to stay at a height of $5 until we get to where t is 1 and mark that with a closed dot. Now we're going to jump up to another height, $10, and that starts when t is 1. So go straight up from where t is 1 and mark it with an open circle. Draw horizontally until we get to the end point, which is at 4. Our final price is $15, and that begins when t is greater than 4. So here's where t is 4. Go straight up till you get to 15, mark it with an open dot, and then extend to the right forever. This graph represents the different rental costs depending upon how many days we rent the equipment for. Now the review assignment goes back to page 223, and there's a story problem about testing red blood cell counts in men and women. We're given some facts. Here's the fact about men, and here's the fact that we need about women. But when you read the actual question, it involves man's blood. So this part about women is unnecessary information. We don't need to know that for this question. We're told that a lab test creates a diluted solution that has 1 part blood to 199 parts saline. Saline is salty water. The question is, how many red blood cells would be in 1/4000th cubic millimeters of the solution? From this statement here, we know that 1/200th of the solution is blood. From this next statement, we know that we have 1/4000th of a cubic millimeter of solution. Let's figure out what 1/200th of 1/4000th is. 1 times 1 is 1, 2 times 4 is 8, and then there's 2 zeros here and 3 more zeros here, 5 zeros. That's 1/800,000th millimeters cubed. From the very first part, we're told that there are 5 million red blood cells per cubic millimeter. So let's take this amount of cubic millimeters and multiply it by 5 million blood cells. 1/800,000 times 5 million on a calculator makes 6.25 blood cells. Now it doesn't make sense to have a fractional amount of a blood cell, so we'll round this down to 6 red blood cells. In this sample of man's blood mixed with saline, there would be 6 red blood cells. Page 221, number 6. We're told that C varies directly as the absolute value of N. From that statement, we can write C equals M times the absolute value of N. Now let's make substitutions using this information. For the letter C, fill in 25. For the letter N, fill in 10. Now solve this equation to find the answer for M. 25 divided by 10 is 2.5. Go back and make another equation with C and N. C equals 2.5 times the absolute value of N. Then find the value of C again if we use -4 for N. The absolute value of -4 is 4, and 2.5 times 4 makes 10. So the value of C is 10 when N equals -4. Number 8, we have an equation with y and x, and there's a k. And we're given values of y and x. Let's make those substitutions. And now solve for k. On the right side, 15 minus 6 makes 9. Divide both sides by 9, and we get k equals 5. On page 219, we're asked to create an equation from these words. So the perimeter of a square varies directly as the length s of a side. So we have perimeter equals something times s. Now, in geometry class, we know that there are 4 sides on a square, so the value of m is a 4. And here's our equation relating perimeter and side length. Number 4, the distance that an object travels at speed 12 miles per hour is directly proportional to the number of hours t. So we're going to make an equation that connects d to t. And right here, we're going to have a number filled in, which is our value of m. That's the 12. So we put in 12 right there. Here's our equation relating distance and time. Page 216, we have function r and we have function t, and we're asked to do this composition. So let's start by finding r of -1. Take the formula for r and fill in -1. This makes -4. Now let's find t of -4. Take the formula for t and fill in -4. And this answer makes 9. Number 32, we have rules for function p and for function q. We're asked to do 2 different compositions. So let's first find q of -3. Take the rule for function q and substitute -3. And now find this answer. This is the same as -3/2, take away 6/2 when you get a common denominator, which makes -9/2. Now find p of -9/2. Take the rule for function p and fill in -9/2. This 2 and this 2 cross out, leaving -9 plus 6, and that makes -3. Now question B, we're going to do the same thing, but in the opposite order. So let's first find p of -3. Take the rule for p and fill in -3. This happens to make 0. Now find q of 0. Fill in the 0, and then evaluate this answer. It turns out to be -3. On page 212, we had an inequality, and we're asked to complete a chart containing 7 values using these choices for x. We know from experience that it helps for this inequality to have the letter y alone. So let's rearrange it. Let's add 3 to both sides. We get x plus 3 is greater than or equal to 2y. Now divide by 2 on both sides. We will get x over 2 plus 3 over 2 is greater than or equal to y. We're used to having the letter y on the left side, so let's switch the sides. I'm being careful to keep the arrow pointing to the letter y. Now that we have an expression that finds values of y, we can find these 7 rows of our table. Let's first substitute -3 in place of x. This creates y is less than or equal to 0. Next row of the table, fill in -2 for x. This creates y is less than or equal to 1/2. Next row of the table, fill in -1 for x. This creates y is less than or equal to 1. I think I see how it's changing every row. It's adding a half. So this is 1.5. This one is 2. This one will be 2.5. And this last one will be 3. We're asked to give the range. That's where you list your y values. But all of our y values are inequality statements. I think the most expansive of them is y is less than or equal to 3. So that's our range. Now let's make the graph. This is the x-axis, this one's the y-axis. We can put lots of marks on here, but we only went to +3 and to -3. So we really don't need to put marks past those. Now on the y-axis, how much should we label? Seems like the smallest we ever got was 0, although we're told y is less than that, so we are going to go down into the negatives. The largest we ever seemed to get was +3, but the pattern continues to go up if we had made more rows. I think I'm going to just count by ones. Let's graph these results. First row of the table, when x is -3, we want to close dot on 0, and then we want to show everything that's less than 0. Draw a ray going straight down. Next row, when x is -2, we want to close dot on 1/2, and then show everything less than 1/2. Next row, when x is -1, we want to close dot at a height of 1, and show everything less than that. Next row, when x is 0, we want to close the dot at 1.5, and show going down from there. Notice the pattern is the dots continue to go up by 1/2 as you travel to the right. Oops, I need to make sure I go through 2 there. And here I need to make sure I go through the 3. And there's that graph. Number 6, y is always equal to -1, no matter what x is. So this is -1, -1, -1, -1. This one's really fast to fill in. Now let's graph this. When x is -3, y is -1. When x is -2, it's -1, and so on. A horizontal row of dots, all at a height of -1. We were also asked for the range. I forgot to give that. It's all the y values. The only number is -1.